Welcome back. So, in the previous lecture, we discussed about that how we can identify the lithology, subsurface lithology, or structures based on the surface morphology. Okay. Now, let's see some examples of landforms which are either related to the coastal erosion or the aeolian, that is wind action, and as well as the water action, that is in fluvial landforms. Okay. So, we have couple of satellite photographs or aerial photographs which are been taken at various point and by us as well as by others. So, we will try to explain you based on that how we can identify the different landforms. Okay. Now, the first photograph which you see on this screen is from Andaman, and this was taken from helicopter, and if you try to see that this is an oblique photograph where you can see the horizon as well as the land. Okay. So, I am not going to go into detail of that, which we have already talked in the previous part, that photogeology 1. Now, what do you see here? Actually, this was taken after 2004 Sumatra Andaman earthquake, and along the this was along the west coast of Andaman. So, the interesting part was that this area got uplifted. So, it emerged from during the earthquake, or by the earthquake it was uplifted. So, the landforms what you see here, as a geologist or earth scientist, you will immediately pick up a very typical deformation here in the sandstone bodies. Okay, or maybe you can say these all sedimentary structures. So, what do you see here is very beautiful folds. Okay. So, you can easily make out this over here. I'll just put in a line here which will, so this goes like that. So, you have an folded sequence here. Now, if you look at here, what you see, the boundary edge I am putting here. Now, this is an area where the water is not inundating it. Okay. This is a portion of the coral reef. This coral reef was emerged at the time of the earthquake. Okay. And then third landform which you see here is this bright portion, okay, which is encircling this island. Then small island. Now, this what we call is the beach. Now, the point here was that usually the water comes up to somewhere over here during the high tide and then recede somewhere over here during the low tide, but now the water has receded up to this point here. That what has been shown here. So, anyways, these are the things which like land level change happened during 2004 earthquake, but the landforms which you can demarcate from this are quite distinct. Okay. Now, coastal landforms, we'll talk in few slides about the coastal landforms. They are related to sea and land contact. Okay. So, they are close to the sea and land contact, or ocean or land contact you will see. Landforms are basically the result of one, the sea level fluctuations, because if you say that the sea level has gone down, then you will be able to see the land. Okay. If it is gone up, then you will see the submerged area. Okay. Now, they are been related to the high sea. If we say that, then it is an interglacial period. Okay, where we have a lot of melting of ice and all that, and then glaciers, and then water is poured more into the ocean, and you have the volume changes. Okay, and it start inundating more and more areas. Okay, and then low sea level, then we have glacial period where you will have reduced volume of water, and you see more land emerged out of that. Okay. And then sea wave erosion is one of the common factor. Mainly the wave actions will result into the formation of different landforms, as well as the deposition of the material along the coast will also result into the formation of different landforms and different environment in that particular area. And of course, the last is the tectonic movements. Okay. So plate motions can also result into the formation of different coastal landforms along the periphery, okay, where you have an ocean land contact. So the coastal processes and associated landforms, if you take, okay, so development of coastal landforms depends on one, the coastal erosion, second is sediment transport and deposition. So coastal erosion mainly depends on dimension of waves. Okay, how high are the waves and what is the tidal range in that area. Okay, configuration of the shoreline, that is the morphology of the shoreline will also play an important role, because not everywhere you will be able to see that similar landforms are formed. Okay, it will vary. Somewhere you will see the cliffy bank cliffs, okay, along the on the coastline. Somewhere you won't be able to see that. Somewhere you will be able to see in development of beautiful beach, and somewhere not. Okay, so that depends on the configuration of the shoreline, strength of the waves to erode, okay, angle at which it meets the shoreline. Okay, so these are few things which are very important, and let me tell you that this all points which have been given here, at least few, okay, like if you say like the dimension of waves, configuration of the shoreline, strength of the waves, these are also important at the time of that, from where the tsunami is going to come and where, how it will hit, what will be the angle of the tsunami, that is the directivity of the tsunami coming and hitting the shoreline. Okay, now depending on the above parameters, following landforms will be seen, like for example headlands, sea cliffs, natural bridges, sea stacks, and your tambolas. Okay, so if you take right from the land part towards the ocean, then you have different geomorphic forms here. Okay, what we can see, the back shore here. Okay, and then you have the coastal dunes, okay, or you can say the bumps. Coastal dunes are here, and then you have the bumps here, and then you have in beaches and scarps here. Okay, then get into the deeper part, you have long trough and all that, but mostly what we are interested in is this one. Okay, so we may have in this area like beach, dunes, okay, and beach ridges, lagoons, okay, back marsh, spit. So how this landforms look like, okay, and how they are formed, we will discuss little bit of that part. Okay, a very typical arc shape erosion, okay, will lead into the formation of your headlands. Now these headlands are typically seen where you are having the rocky areas. Okay, otherwise you will not be able to see such landforms. And then again, and a very circular or arc shaped landform which has been formed adjacent to that, we term that as an bay areas. Okay, so you have, if you are having the rocky coastline, then you may be able to see, depending again on the energy of the waves and how the waves are hitting the coastline, you will be able to see the cliffy banks, okay, or sea cliffs. Then if you are having the circular erosion, like crescent shape erosion, that will be giving you the bay areas, and between two bays you will have an headlands. Okay, now can we see such features on surface? So this is an example here. Okay, fine. So you see a very clear cut, and not exactly the bay area, but a very small crescent shape here and over here also, okay. And then you have an headland. So this you have, this is the surface here and this is the cliff which you can, and so this is again an oblique aerial photograph which was taken after the 2004 Sumatra Andaman earthquake, okay. And this area which you see right now, okay, is an area which got immersed during the earthquake, okay. So earlier the water used to come up to this point, but now it's up to here only, okay, fine. So this is an area got, what we say, uplifted. So this is an example of the headlands, okay. Now there are many other related environments which you will come across close to the coastal regions, okay. For example, you will have a most common tidal flats, okay, which have been seen, where the tidal flats mainly will have a tendency of getting inundated during the high tides and will be composed of very fine deposits, okay. So mainly we can also say mud flats, okay. Then depending on the configuration of the shoreline, you may have the formation of dunes, okay, or we also often term this as in beach ridges, okay. So you have in coastal dunes which will protect the inner part of the coastal area, okay, and that protected areas are termed as lagoons, okay. Now lagoons will have an two-way like supply of water. You have marine water getting in during a high tide, as well as you are having the water coming from the rivers, okay. So that is the fresh water, as well as, so you have in something like what we call the brackish environment, okay. So lagoons will be quiet areas mostly, and will have a different environment than the ocean, okay, fine. So here you will see what for example, it may be at or above mean sea level, okay. Then we have like marshy areas, again that will form behind the beach ridges, okay, or you say the coastal dunes, okay. So marsh areas will also be associated with that. So and another erosive landforms which you will come across, yes, of course this is but will be a bit difficult to identify from the satellite photo if you are having ortho photographs, but if you are taking oblique aerial photographs, you will be able to pick up such erosions, okay. So these are the natural bridges and arcs which are commonly seen. There is an example from Australia, okay. It's again another example of natural bridge which is informed, okay. And then you have headlands as well as the platforms, okay, erosional platforms which have been seen. Now, as I told that if there is either the tectonic movements which will uplift the area, or there is an sea level fall or rise, okay. Now this phenomena will, or the process will result into the formation of terraces, okay. So you will have flat steps, okay, which have been formed because of the change in the sea level. So what does it indicate? This step or this point, it indicates the ancient sea cliffs, okay. And this sea cliff, the present sea cliff is this one. So this is the present sea cliff. And these are all ancient sea cliffs, okay. So what does this tells us? That at one point of time the sea was up to this, okay, similar to what we see now here, okay. And suppose the sea level falls, then we may have another step coming up here, okay, fine. So this also indicates that this landforms, what we call marine terraces, okay, are the indicative of ancient sea levels. Okay. Now along with that, as I told, that either the sea level goes up or down, we may also come across some drowned beaches. Okay. Now can we see this from the satellite data? To some extent, yes, of course we will be able to mark this. Okay. Let's see a few examples of that if possible. So these are the sea cliffs. You are having all flatlands here in the top here, and these are all sea cliffs you can see. Okay. Now if you are having similar multiple higher terraces or this, then you can easily talk about that these are the paleo or the ancient sea cliffs or the terraces. Okay. Now shore platforms are the horizontal surfaces formed in rock at the base of the cliff. Okay. So you have, for example, a rocky cliff coming like that, and then you have a shore platform. Okay. So the shore platforms or the wave cut platforms are the erosive platforms at the of the present sea level. Okay. This is what we were talking about. Then this is typical of Tambulu. And lagoons, as I was talking about, that it will be enclosed to some extent. This also is partially a lagoon. Okay. But if it has been covered or protected by an sand dune or the beach dune, okay, then you will be able to see similar features. Then you have an spit. Okay. Now spits will form, which will be a function of your longshore currents. So if we consider this, that a longshore currents which are flowing in this direction will result into the formation of spits, or in very longitudinal linear beach or dunes. This again depends on the configuration of your coast. Okay. Because if your currents are coming and directly hitting like that, then it will not allow you to form this type of features. That is what we call spit. Okay. So this is highly dependent on the coastal configuration as well as the direction of your long currents. Okay. How they are flowing. Okay. So this will give you, so spit, just keep in mind this one, we'll see some example of that. So shore platforms, so we, as we discussed, we have cliffs here. These are your cliffs, and in front of that you have a flat area. Okay. So this is your shore platform or wave cut platform, also we can see that. Okay. This is an example from Andaman. So we have a typical sedimentary rock sequence which you can pick up. So we have a cliff here, and this is your wave cut platform. Now, as I was talking about that, we identify the marine terraces. Okay. So marine terraces, or what we call is the ancient cliffs. Okay. So this is a present one, this one is an older, and this one is here. Okay. And some places we will also be able to see the drowned beaches. Okay. So if you carefully see this photograph, what we see is that this slightly whitish portion here, which I can demarcate. Okay, which goes like that. Here the boundary I'm putting a very rough boundary. Okay. Now this is my drowned platform. Okay. This one here, which goes from here like this, this is your present wave cut platform, and this is your higher surface. I am drawing this here, and this is your cliff actually. So this becomes my terrace. So this again from Andaman, oblique aerial photograph, and we were able to fix up multiple terraces. Okay, this is also one terrace here which goes probably, yes. Now coming to the wave cut platforms, result of cliff erosion. Because of the result of the cliff erosion, it will occur below high tide, okay, and slope seaward. So it will be something like that, okay. So it will be sloping like this, okay, below high tide. Okay, so suppose your high tide is coming right up to this, so we will say, okay, fine, this is below the high tide because it will go long towards the ocean, okay, fine. As erosion occurs, it is wider and shows the marine erosion of cliffs, okay. Waves enter shallow waters across platform, which slows the movement, okay, fine. So this is another example of the wave cut platform which you can see. Okay, you have cliff and then the erosion which has been taking place by the present day waves. Similarly, here you have the wave cut platform as well as the beach you can see over here. Now this is a very important portion, the formation of sea notches. But if you again you take an oblique aerial photographs, you will be able to pick up the sea notches, but if you are having ortho photographs, it will be a bit difficult, okay. So sea notches again are the erosional landforms resulted because of the wave action, and mostly will be seen where you have the rocky shorelines. Otherwise it will be difficult to have such features, okay, so notches, okay. And this also indicates the range of the tides, okay. So the range of the tides, that is this point is your high tide and this is your low tide, and then center of the crust will be your the mean tide, okay. So this is what has been shown here, okay, fine. Then you have a high tide here, you have a low tide, and this is the portion which you will have the mean tide, okay. So this shows the tidal range, but suppose the notch goes like that, okay, fine. So then it is difficult to say that this is the tidal range, okay. So it may be a sort of what we call the cumulative notch, which has been formed because of multiple phases of erosion, okay. When I say multiple phases of erosion means that I'll show in the next slide, okay, that because this notch will indicate your present day sea level, okay. Now suppose you are having such notches sitting at the higher platforms, okay, which we call as a marine terrace as well as the old platforms, and then you have the sea notch, okay. So the previous sea level was over here, and then you were having this, you can say the high tide, this was low tide, okay, and then you had the formation of the sea notch here. Subsequently the sea level has reduced, okay, or has fallen down, and what you see is the present day platform, new platform, which is sloping towards the ocean, and then you have a new notch which is coming up, okay, as well as the new wave cut cliff, okay. So wave cut cliff, sea notches, platforms, wave cut platforms, you will be only coming across where you are having the rocky shorelines, okay. Now this is a beautiful example from Andaman, which shows you two typical landforms, okay. One is the, or I can say three, okay. So one is your bridge, then you have sea notches, and wave cut platform. this is a present day wave cut platform, and then present day notch is sitting over here. Okay, and these are all older sea notches. So this was the platform, and this is notch. This is the platform, and this is notch. Okay, and this portion is your bridge. So keep in mind all this landforms, and when you are doing the satellite data interpretation of the coastal regions, you may, as I told, that you may come across such landforms. Okay, like for example, I'm emphasizing on the point that sea notches you may not be able to identify, but along some coastlines, okay, again depending on the type of or the configuration of the shoreline, you may come across such features. Okay, for example, this you will not be able to see where you are having a totally flat shorelines. You need to have the rocky shorelines for having such features. Okay, so in some cases along the coastlines you may come across this, depending on at what type of shoreline you are looking at. Okay, again similar examples of spit and lagoons and barriers, some more cartoons showing the depositional and erosional landforms. So I'll stop here and we'll continue again in the next lecture. Thank you so much.